There's a fine line between hard work and failure and hard work and success. Only a very small fraction of the hypotheses that we follow really turn out to be true. You are asking questions that nobody knows in order to really bring the field forward. And the few hypotheses that turn out to be true are so rewarding that this clearly overshadows the disappointments that you face when you do biological research. My name is Timo Müller. I'm the director of the Institute for Diabetes and Obesity here at the Helmholtz Diabetes Center in Munich, Germany. The desire to become a biologist was already burned into my head very early on. When I was 19 and I just moved to the university, I found a letter from the kindergarten saying that Timo wants to become a biologist. What we are doing here at the Helmholtz Diabetes Center is really cutting-edge research that focuses on answering biological questions that will potentially be of benefit for the public and the scientific community. My father was a biology teacher. He's now retired, but he was one of the motivations for me to become a biologist. I was lucky enough at the university that we had one group that worked on diabetes and obesity, and I stayed in obesity and diabetes research ever since. After I received my PhD, I joined Matthias Tschöp's team at the University of Cincinnati to work on the first set of dual and triple agonists. I was very soon convinced that these concepts have immense potential. The entire institute comprises roughly 100 people divided into 11 groups. Every group has a certain specialty. I'm also heading the group of molecular pharmacology in this institute, and we are focused on the development of novel pharmacotherapies to treat obesity and diabetes, and also to understand the mechanisms of how these drugs act in the brain and the periphery to regulate glucose and energy metabolism. We have projects going on to further expand this concept of unimolecular polyagonism by designing drugs that bring nuclear acting hormones only in specific cells. And one of the key discoveries that we made in the last years is that we identified the brain GIP receptor as a key regulator for decreasing body weight and food intake. The impact of our research in obesity and diabetes is sizable. The drugs that we conceptually developed, which have then been pushed forward by lead pharmaceutical industries like Novo Nordisk or Eli Lilly, they are able to decrease body weight in obese patients without diabetes by up to 25–30% within 72 weeks treatment. Around 40% of these patients achieve weight loss greater than 25%. To see that our concepts translate into the clinic and can really help patients, this is the biggest reward you can get as a biologist. Especially when you get revision studies. It's not uncommon that we have 20 people working on the same project, 8 hours, sometimes longer a day. And when then the paper gets accepted, right, it's a team achievement. It's not only the achievement of the first or the last author, it's a team achievement. In my free time, I'm a very passionate scuba diver. The excitement and the adrenaline rush that you get from seeing a big predator like a shark is pretty much comparable to the acceptance letter that you get when your high-impact paper is accepted in a major journal. The Helmholtz Diabetes Center has grown over the last decade into several institutes, all working very focused on specific questions associated with obesity, diabetes, cancer, and all the comorbidities that are associated with diabetes. And the Minkowski Prize is, without question, a very prestigious honor, not only for me, but also for the entire Diabetes Center and for Helmholtz Munich. When I found a letter from the kindergarten saying that Timo wishes to become a biologist, I have to admit that I had no idea what this means, being a biologist, when I was 6 years old. And still, if I now look back in time, I could not have imagined ever sitting here and receiving such a prize for my research career. Every day I enjoy coming to work, talking to scientists, see new data of whether our hypotheses turn out to be true, and then seeing how slowly a project develops from a hypothesis to a manuscript or even a drug. It's really a great reward for my daily work. The energy actually that I basically take to continuously perform diabetes research is, of course, my family. My wife is very supportive and really appreciates the value of me being a scientist and what this means, being married to a scientist. And without my family, all this would, of course, not be possible.